Hello. Are you able to hear me now? Yeah, screen is also visible, right? Okay, actually I lost my power supply. Right now I am on my mobile data. Okay, fine. So what's the last thing that you had before I left the meet? What's the last thing that you had before I left the meet? Read data. Okay. Yeah. So I'm just going back to the program. See, here we have stored the data, and along with the data we have stored the generated CRC. Okay, here we generated the CRC, and here we have stored the generated CRC. Here we read the data. Okay, so after not only we read the data, but we are also reading the same stored CRC. Whatever we generated earlier over here, we are reading the same. Okay, the same, we are reading the same thing. So again, what we are doing here, there are two approaches. So can you just tell me, Ibrahim, when do you think the data is not corrupted? Okay, when do you think that, what's the condition you think so? So basically we have data inside the EEPROM memory, and we also have the generated CRC inside the EEPROM memory. Okay, we have generated CRC and the original data. Okay, and then we are fetching the original data, and along with the original data we are also fetching the same generated CRC. So we are fetching the same generated CRC, but not only doing that, we are also generating the CRC again. Okay, we are also generating the CRC again. So now we are doing the validation whether these generated CRC and the stored CRC are both are same or not. If both are same, then the data that whatever we stored inside the EEPROM memory is correct, or else it is not correct. It got, it is corrupted. So is that clear? We have the main data inside the EEPROM memory. Along with that, we have stored the generated CRC. Now we are fetching the original data and the generated CRC, and again we are regenerating the CRC from the data. Now this regenerated CRC and the stored CRC, are both these matching or not? We are performing a simple check with the help of if condition. If both are same, then the data is original. Okay, or else it is corrupted. So up to here, is that clear? Now I will jump into how to generate, what is the actual, see, what is the main concept behind, like how we are able to generate that encoded form. Okay, now I will discuss, which is very difficult to understand. Okay, so I hope up to here everything is clear. Now I am discussing about this particular function. So Shigarani, are you there? From here you can also continue listening. Yeah. So now, before that, let me start the stream, YouTube stream. I think it's already going on. Yeah. So now I will be explaining you how this particular function, calculate EEPROM CRC, is able to generate the checksum, CRC checksum for the day from the data. So this is accepting one parameter, right? Data size. So how many bytes you are storing inside the memory, you need to pass that particular value. Okay. So, do you think checksum can be generated directly with the help of number of bytes, or we need to take that original data as well? What do you think, Sir Ibrahim? Can checksum be generated directly with the number of the memory, how much of memory it is occupying, whether 1 byte or 2 byte, or we need to fetch the original data? What do you think, sir? And one more thing is checksum should be unique. Okay. So if you change the string, if you add one more character, let's say instead of hi, if you put by, okay, bi, so then checksum would be different. Okay, if the characters which is present in the memory, if it varies even a single character or not just going to the character, even if just a single byte inverted, then it checksum would be different. So do you think only the data size is enough, or we need to take the original memory, read the original memory to generate the checksum? What do you think, sir? So there are two options. Option A, only data size is enough. Option B, we need only we need actual memory, actual data that we stored. Option A, option B. So just post a message A or B. That's it. I think only data size should be enough. No, no, not exactly. See, with data size, what can you do? Isn't it? We need the original data, isn't it? Let's say, so Ibrahim, your name contains how many characters? 1, 2, 3, 4, 5, 6, 7, right? Ibrahim. 1, 2, 3, 4, 5, 6, 7. Yeah. Ibrahim name is containing 7 characters. So 7 characters means 7 bytes. So data size is 7. Okay. So now let's take one more other name, some other name, which may also contain 7 letters, isn't it? So now, if the CRC generation is only dependent upon the data size, so then it's a possibility. So that means what you are from what's your analogy. So you need, which implies that checksum is same for both, irrespective whatever the characters present inside the name. Though the names are different, if it is containing the same characters, I mean, same number of characters, not same characters, same number of characters, or else the same data size. Okay, then the checksum is same. That's what you are saying. So now do you think is it true? Or now will you be changing your opinion? Right? Yeah. So your statement is wrong. So it is not dependent upon the data size. It's dependent upon the actual data. Then why we need data size? Isn't it? Because the function needs to know, different names may have different number of characters, isn't it? So the function needs to know how many characters that you are trying to store, how many locations you utilized in the EEPROM memory. Okay. So in the EEPROM memory, how much for how much of memory you need to generate the CRC. So here we have used two locations, that is 0 and 1. At 0th position we stored letter H, and at the first position we stored the character I. So that means we have occupied already, the two locations are occupied with the data. So here we are passing the data size, but why we require data size? From data size, see data size, it's not the primary thing. The main intention is to first fetch the data, original data. To fetch the data, we need to know what's the data size, isn't it? When you know the data size, then you can fetch it. If the data size is unknown, you cannot fetch the data, isn't it? So that's why first we are accepting one parameter data size just to determine how much of data is stored in the EEPROM. So once if you pass 2 over here, so then this function understands that, so there are two locations in the EEPROM memory for which you want to generate the checksum value. Okay. So then it will start processing, actual checksum processing. Okay. So now that thing we need to discuss how it is processing, and how it is going to happen. Okay. So is that clear, Ibrahim? Up to here, is it clear? Yeah. So now I will be discussing something which is very essential, very important, and very difficult to understand as well. Okay. So let's start with the first line. Okay. Let's start with this particular line. So here there is something like 0L. So what does 0L mean? 0L. So basically L means long. Okay. Just remember. So L means long. Okay. So it is something like a data type, just to indicate that it's a data type, long data type. So what is basically meaning, what does it mean? If you are taking a long data type, it means it can store 4 bytes of memory. Okay. It can store 4 bytes of memory. And floating point, floats can also store 4 bytes of memory. And coming to integer, integers can store only 2 bytes of memory. Okay. And character can store 1 byte of memory. So this is the different things. Okay. Memory allocation for data types. So here L refers to long. and here we are having 0, right? So see, what does 4 bytes mean? So for one, we know that 1 byte is equal to how many bits? 1 byte is equal to 8 bits. So 4 bytes means 4 into 8, 32 bits. Okay, so this is a 32 bit. Okay, this particular whatever we are taking over here, it is 32 bit. See, whenever you use the long, the data type long, it means that it can store 4 bytes of memory. So 4 bytes means 1 byte is equal to 8 bits. 4 bytes means 4 into 8, 32 bits. So that means now this particular, whatever the variable which you declared specified this particular variable to be of data type long, then this particular variable can store 32 bits of memory. Okay, so this each individual bit can be either 1 or 0. Okay, so now what we are doing is like, we mention it is 0. That means all 32 bits are zeros, like the total 32 zeros. Okay, and then we added one more symbol before that. So this particular symbol is used to invert the bits. Okay, let's say, see, this is 0, right? Or else if I take this particular symbol before the 0, so now the value becomes 1. Okay, if I take this particular symbol before 0, the value becomes 1. Similarly, if I take the same symbol before 1, okay, now the value becomes 0. So that means this particular symbol is used to invert the bits. It is used to invert the bits. That means all the bits which are having high, that means which are 1, ones are converted to zeros, zeros are converted to ones, in the other sense, vice versa. Zeros turn into ones and ones turn into zeros. So that is the thing about this particular one. Okay, now what happened? We are having total 32 ones, isn't it? 1 1 1 1, like that. How many times? 32 times. Okay, so 32 times. So we see, here you need to know one thing. Okay, yeah, so total there are 32 ones, right? Up to here, is it clear? Up to there, is it clear? Yeah. Now what we see, in the calculate EEPROM CRC function, we have taken the data size, and then we have taken one variable. Basically this particular variable is having totally 32 ones. Okay, as its value, 32 ones, binary ones as its value. So this is the, instead of mentioning 32 ones like that, this is the shortcut. Okay, this is the shortcut. Or else if you want, you can take ones. Okay, but that's not correct approach. So this is the easiest way, shorthand property. Okay, or else you can take in the hexadecimal. So those who know how to convert any binary to hexadecimal, so they can do that. Okay, so 1 2, total we require 6 f's, 1 2 3 4 5 6, yeah, 8. So this is the in the hexadecimal representation. So this is the hexadecimal representation. Now in this particular, see here we have taken a for loop. Okay, in this for loop, what we are doing is like, the main intention of this for loop is to read the value from the data size. So I already told you that with data size you can do nothing. Okay, with only data size you can do nothing. You cannot generate the checksum value. So you need to read the data. So now what you are doing is like, uh, we have taken one for loop. So see, for here you have given the one taken, you have taken one variable index. Okay, or else you can take I is equal to 0 for simplicity. I is equal to 0, I less than data size, and plus plus I. Okay, this is pre-increment operator. So we are not going to explain what is pre-increment operator and post-increment operator. Those are covered in C language program. Okay, in introduction to C programming. There you can learn about this pre-increment and post-increment operators. So you have taken a for loop, and in this for loop, you are having first you have taken a variable I, for which you have assigned the value 0, and then you have taken one condition, I less than data size. Okay, so in our particular case, what's the data size, Ibrahim? In our particular case, what's the data size for the memory that we are storing in this particular program? According to the data, what's the memory size? Data size. Is it 1 or 3 or 5? What is the value of data size? It's 2. Perfect. So it's 2, right? So data size is 2. So initially, see here what we are doing is like, initially we have assigned I is equal to 0. Uh, Initially we have assigned I is equal to 0 and I is less than 2, comma, plus I. That means this plus I means plus, okay, or else yeah, I can do like that. That means, see, till this particular condition is satisfied, till this particular, see, whatever the condition that you have mentioned in the second statement, till this particular condition is satisfied, this whatever the whatever the instructions, the set of instructions that you have written inside the for block, okay, this particular uh, inside the for condition, these will be executed repeatedly till when this particular condition is satisfied. Okay, so to make this condition get satisfied at a point of time, so we are adding this pre-increment operator. So first initially why I value is 0, so that's why, which is, see, this I value is already less than 2, so that's why first time this program gets executed. So again what we are doing, we are incrementing the I value. So next time I becomes 1, the value of I becomes 1, and again I is less than 2, this condition is also satisfied. So that's why again these instructions are executed for the second time. So on further increments, see, it won't get executed if you take I is equal to 2. So I less than 2, which is actually unsatisfied, because 2 is not less than 2. Okay, it is equal to 2. So that's why whatever the instructions which are present inside this particular for block, these are executed for 2 times. So from your observation, what you need to understand is that our data size is 2. Okay, and what we have did is like, we have taken an empty CRC variable which actually contains 32 ones. 32, it's a 32-bit integer, all bits are ones only. Okay, all bits are ones only. And then what we are doing, whatever the data size that this particular function is accepting, for the same number of for the same number of times, we are executing these particular instructions which are present inside the for block. Okay, now again we will jump into this particular line. Okay, this particular line. So what we are doing over here, we are reading the value. Okay, we are reading the value. Is that clear? We are reading the value. Are you able to follow? Ibrahim, are you able to follow? Yeah. So actually it is very difficult to understand. Uh, See, here there is something called mixing process. Okay, mixing a procedure which happens in the background. So I just don't know whether I will be able to make you to understand or not, because it is very complicated to even explain. Okay, that is such a higher concept. So it's not very easy to understand how this CRC is generated, how the CRC checksum is generated. That's very difficult to understand. So unless you focus concentratedly, neither I can be able to make you understand, and you will also not be able to understand. Okay. So now here we are reading the data. So how many times we are reading the data? We are reading 2 times, not just 1 time. We are reading 2 times because data size is 2. So if it's 2, then the for block is executed for twice. Okay, so that means we are 2 times we are reading the data. But how this process is going on, we are not reading the values immediately. See, let's say at first position we already know, at 0th position the particular value is h. So I said that we are reading the value 2 times. That means we are not immediately reading the I value as well. Okay, we are not reading immediately, because after reading the h, okay, after reading the first value, we are doing some processing over here. After this particular process, again we are reading the next variable. Okay, after reading the next variable, again doing the process. Okay, is that clear? We are not reading two values at a time. First we are reading the first value, then doing some process, again reading the second value, doing some process. Similarly, depending upon the data size, the same number of times, how many bytes of memory you stored in the EEPROM, the same number of times you are repeatedly reading the data and doing some process, repeatedly again doing, reading the data, doing some process till the condition is satisfied. That means till the same number of times the program got executed. Okay. So now we will see how the CRC is generated. Okay, till here, see now what we did, we read the first character, that is H. Okay, we read the first character H. Now this is very important to understand. So this is very difficult to understand, this particular line. Okay. So now I'll see. Will you be able to interpret that? I will show my screen. Do you think will you be able to interpret that? That's very difficult to understand. But still I will try to explain. So focus, listen focusfully and focusly. So here we are using an operator, right? So can you just tell me what do you think this particular operator could be? See, it is having two greater than symbols. This particular operator. What do you think it could be? What do you think it is called? No idea. So you know about this particular operator? Any idea about this one at least? See, it's a comparison operator. If it's greater than or less than, okay. If you are having only single greater than symbol, then it is a comparison operator. Okay, it is a comparison operator. But if you are having two greater than symbols like this, so that is we call it as shifting operator. Shifting operator. So only one greater than symbol means it is comparison operator. Comparison means you are comparing between two quantities or two different things, which is greater, which is lesser, just for a comparison. But if it is having two symbols, two greater than symbols, it's not a, no more it's a comparison operator. It is called a shifting operator. So if you are having greater than symbol, see, it is showing the right side direction, right? So that's why this is called as right shift operator. So again, I am telling, if you are having two greater than symbols, it is called a shifting operator. So if it is pointing towards the right side direction, it is a right shift operator. If it is like this one, okay, then it is the left shift operator. In shifting operations, we have two different things. One is right shift operator and another one is left shift operator. Okay, first one is right shift operator and another one is left shift operator. So unless you know about these shifting operations, it is very difficult for me to explain how this CRC is generated. Okay, and here you can find one more symbol, right? Up arrow. So any idea about this one at least? Any idea? I'm pinning that symbol. Any idea? So this is actually called as XOR operation. Okay, XOR XOR operation. XOR operation. So XOR means exclusively OR gate. So today I am giving you an assignment. So there are so many gates: AND gate, NOT gate, NOR gate, OR gate, NAND gate, okay, XOR gate. AND, NOT, NOR, or else you can, okay, NOR, OR. First we will put OR gate. Yeah, first we will start with AND gate, NOT gate, and then NAND gate, then OR gate, then NOR gate, then XOR. So you need to, today assignment is you need to learn about these gates. You do research and submit an assignment, handwritten assignment. Okay, you can post in the group. So this is today's assignment: AND gate, NOT gate, NAND, or NOR, XOR, exclusively OR gate. So after after you are done with the assignment, then you will be able to understand the XOR gate. Then we can continue how this particular operation is performed. So if time permits, also try to do a little bit of research. I will also explain about R shift. So what does R shift mean? Right shift. It's a shortcut form. Okay, R shift and L shift. That means right shift and left shift operators. So these two things are your today's assignment. And not NAND or NOR, XOR, exclusive OR gates, and R shift and L shift, right shift and left shift. So this is the today's assignment. Is that clear, Ibrahim? See, I will run the code and I will show you. See, I am just running the simulation. So we need to open the serial console. Yeah, code is getting compiled. Maybe it is taking some longer time. So let us also check with some other thing as well. Okay, I'm just clicking on simulation. I'm going to simulation and I'll click on simulate button. Yeah, code is getting some error I'm getting. Okay, so we have changed the variable name, right? uh, Index, index. Because here, see here, if I change it to I, so here also I need to change it to I, right? But here I haven't changed it, so that's why we got that error. Or else we can change everything into I. Yeah, now I'm just simulating again. So still it is taking longer time. Already we have actually simulated the same code yesterday. The same code actually we simulated yesterday. Looks like maybe it is taking, see, we are not using the premium one, so that's why it is adding some delay. It is putting our compilation in queue, so that's the reason. Okay, just check the yesterday's session. We have already shared the CRC video where the program has been executed. So let's wait for a few minutes. If it produces the output, it's fine. Or else if it takes even more time, then we will end the session. Just check, go back and check that particular video. See, build servers busy. So this is problem from their end, from the simulator end. Yeah, that is the simulator issue. So you can just check the yesterday's session where we have already executed this particular program. So where we are storing high, and then we are generating the checksum. We are storing this checksum in the EEPROM, and then we are recalculating the checksum, and we are just checking if the generated checksum which we stored earlier and the regenerated checksum, if both are matching or not. So if it's matching, then the data is no, uncorrupted. Okay, I hope it's clear, right? Today's session is clear. So any questions you want to ask before I wrap up the session? I hope it's clear, right? Yeah. So also Ibrahim, gentle reminder that it's already been so many days that we have been trying, our team have been trying to reach out to Mr. Abdul Hafiz, but unfortunately maybe due to his some work, I think he's not responding right now. So already we have given a lot time. We have some pressures from the sales team and the accounts team. So just I request you kindly please just remind Abdul Hafiz to complete. So out of that, at least the current ongoing course fee needs to be paid, right? So we haven't yet even received the payment for ongoing courses. So kindly please remind him and let him complete as soon as possible by today itself, because already it's been long that we have been trying to intimate him. So I hope today's session is clear, and I will be wrapping up the session right now. So you have anything you want to share, Ibrahim, or shall I end the session? Can you just react with them? Okay, fine.